thanks again for joining us this morning for our webinar about electronics cooling with SolidWorks Flow Simulation. We're going to talk a little bit about the software, SolidWorks Flow Simulation, how it's used in the electronics cooling industry, and also talk a little bit about our services and how we've helped customers with their electronics cooling problems. So let's get started. So the agenda today, again, we'll do some quick introductions, talk about who we are. We'll talk about, just in general, why do people want to use things like SolidWorks Flow Simulation, using analysis in their product design cycle. Talk about electronics cooling inside SolidWorks Flow Simulation. We're going to talk about some customers and some case studies, and then just some closing remarks and just a summary of some of the topics that we discussed. Start off with introductions. The voice that you're hearing is me, Jared Conway, Simulation Services Manager over here at Hawk Ridge Systems. Been here for a long time, I think, 9 years. Most of my time has been spent on SolidWorks simulation. Have spent a little bit of time in the applications engineering role, teaching, showing customers, going out and visiting customers, helping them with SolidWorks and SolidWorks simulation, and now focused solely on our analysis consulting and training services from the simulation side of things. Also with me today is Chris Ma, my simulation engineer, guy that gets most of the work done around here regarding our analysis consulting engagements and also a lot of the training that we do for our customers. Been here for 5 years, has a master's in mechanical engineering from UCLA. Also have been awarded the Elite Applications Engineer Award so far. So, you know, our group here at Hawk Ridge Systems, what we are is the analysis consulting and training services group. A couple of webinars ago, I actually talked about this pyramid, which I call the knowledge pyramid. It's a way to describe the ways that people get help with software. You know, it starts at the bottom, things like online resources, documentation, also knowledge bases, et cetera, et cetera. And at the very top are the services that we offer through our group. At the very top is consulting, you know, being able to take your guys' problem and solve it for you if maybe you don't have the software, don't have the time, don't have the resources, whatever it ends up being. And also mentoring, which is really a one-on-one application-specific training on your guys' analysis projects. And kind of how the pyramid works is at the very bottom you may take a lot more time, a lot more of your effort, a lot more resources to get what you need. At the very top, you know, your return on your investment is a lot higher because you're really offloading or you know, providing us the details to be able to go off and solve those problems for you. You know, in our group, it's myself and Chris right now, but we are also backed up by the rest of the Hawk Ridge Systems engineering team. Right now, we have about 60 guys on staff. You know, we have a huge amount of experience in engineering, and really our focus is on the application of SolidWorks and SolidWorks technology to the problems that you guys have today. And again, our group does the simulation services with all the SolidWorks simulation products. So we're talking about SolidWorks Simulation Premium, Flow Simulation, Sustainability, Motion, Plastics, and Flow. And again, even if you have a problem that is outside of the scope of those tools, let us know. We'll probably have a way to help you out. And again, we're flexible. There's no problem too small or too big to help you out with. Don't hesitate to call us if you're not sure if it's something we can help you out with. We'll find some way to help you out. So, you know, everybody that's joining today probably is aware of, you know, analysis and how it's been used inside of the product design cycle. I just wanted to kind of touch on a few topics on why people are really looking at using analysis in their day-to-day design process. So a big thing that I think for me is that analysis allows us to solve problems that really can't be calculated in any traditional manner. You know, we know we have equations for things like a cantilever beam, but do we have an equation for a cantilever beam with a hole in it? No, we don't have that. You know, we have to make a few assumptions about, hey, maybe it's two cantilever beams in parallel, or that we look at things from the perspective of the smallest surface area or the cross-sectional area. So with SolidWorks simulation, you know, we could do things that we can't easily calculate traditionally. The next thing is really reducing the number of prototypes that need to be built. In the traditional design process, we come up with a design, we build a few prototypes, and we go out and test it. And maybe we have 3 or 4 tests that we want to do. Each one of those tests require a prototype to be built. That can be expensive, especially if the first time your prototype doesn't actually survive that test. So with SolidWorks simulation, one is we can build virtual models really quickly and test them without having to actually build anything. So we get 2 advantages. One, there's no cost for building those prototypes, and 2, we can use the same prototype to run multiple tests on it. I think another one that's really important is the ability to pull data out of your tests. There's only so many, for example, in flow simulation, there's only so many thermocouples that you can add inside your physical test. In SolidWorks simulation, any face, any edge, any point, anywhere inside your model could act as a thermocouple, somewhere that you can select and pull the data from. That's really advantageous when it comes to understanding what's happening inside your system. Same thing goes for, if you look at flow simulation again, is you could use a dye test to understand how the flow is actually behaving, but that's complicated to view. You have to have inside your simulation, you have to have, or inside your physical test, you have to have a video camera, or you have to have a assembly that's completely clear. Inside SolidWorks flow simulation, that's the intention of the tool, is to be able to visualize and understand the flow without having to have those complicated setups. And last, again, it all comes back to accelerating your product design cycle. We know that in the traditional design cycle, we're designing, we're testing, we're building prototypes, we're testing. If there's a problem, we go back to the design. If we can move those prototypes and testing earlier in the design process, it allows us to accelerate the product design cycle. So again, just to kind of reiterate how it really works is, if we move the validation and prototype earlier, we shorten the design process, saves us time, saves us money, saves us effort in the long run, and also we get all those additional benefits of virtual prototyping, which is really things like additional results, not having to build things, et cetera, et cetera. So SolidWorks analysis tools that exist today. Anybody that's using SolidWorks Premium today has access to static analysis and motion simulation. Both of those tools are kind of the bread and butter when it comes down to mechanical engineering. And even if you're not using SolidWorks Premium, all of the SolidWorks packages have some Express tools, and the Express tools allow you to do the basic types of analysis. So we have Simulation Express to be able to run static simulation. We have also Flow Express, allows you to run really basic flow analyses. There's some other ones in there for other tools, but really those are when they come down to for Express tools for simulation. If you jump up to SolidWorks Simulation Professional, we add a whole bunch of additional study types: frequency of buckling, thermal analysis, drop test, fatigue, optimization, pressure vessel. These are all really good complementary analysis tools to those that are doing a slightly higher level of design and analysis. And we take one step further into SolidWorks Simulation Premium. The most common ones I think people are using are nonlinear analysis and also time history analysis. But this, in SolidWorks Simulation Premium, we're really bringing it into the dynamic and nonlinear capabilities for your design process. So if you use a shaker table to test into your project, then dynamic analysis is a good fit. If you have plastics, if you have fancy materials, if you're looking for very large deformation, or if you're looking for things like plastic deformation, nonlinear analysis will really help you out in your design process. And then we have a couple add-on tools. First one that we're going to talk about today is SolidWorks Flow Simulation, and it has 2 modules: electronics cooling, which we're also going to talk about, and the HVAC module. We have sustainability, which allows you to understand the product, the sustainability effects of your analysis or your design. And also SolidWorks Plastics, another great tool for understanding the flow of plastics inside your part to understand, is it going to fill? Are there going to be any defects? Are there going to be any problems in your manufacturing your plastic parts? A really awesome tool that we got a couple years ago. So, kind of take a step back and really focus on SolidWorks Flow Simulation for anybody that hasn't used it or hasn't heard about it. It's a general purpose CFD tool. And CFD just stands for Computational Fluid Dynamics. We all know from our original fluids classes that it can get really complicated to solve fluid flow problems. Again, going back to our analogy about existing equations, we can solve for the flow inside of a pipe pretty easily. But as soon as you start adding bends or multiple branches, those equations start to get pretty complicated. So tools like SolidWorks flow simulation solve the Navier-Stokes equation to really understand what the fluid flow is inside of a complicated system that isn't easy to calculate by hand. And being a general purpose CFD tool means that it can do a little bit of everything. So I put down a couple of examples here. For example, it does fluid flow, so we can understand pressures and velocities and flow rate, but also does heat transfer. So things like understanding the temperatures, using or calculating conduction, calculating convection, calculating radiation. It does a little bit of everything. And when you look at the different types of verticals that it serves, there pretty much isn't any vertical that it doesn't serve. Aerospace, it can do flows over top of a wing. Electronics cooling that we're going to talk about today. Even pipe flow problems or understanding the flow inside of maybe a data center, inside of a room to understand how the HVAC works. Another piece that I have here is internal, external, and mixed environments. This is the types of analysis that it actually does. So an internal analysis might be something like your electronics enclosure, an external analysis like your wing, and mixed environment. If you have flow that goes over top of something but also goes on the inside, we can also handle those mixed environments. The next piece there is steady state and transient analysis. Again, most of the time, the work that I've done here at Hawk Ridge Systems, most of the time people are looking at, what happens over a long period of time. But also there's components and understandings that you may want to have around what happens over a specific period of time. So for example, talking about our electronics cooling, we may have an electronics enclosure that we turn on at T equals 0 seconds, and we want to ramp up the heat from 0 to 10 seconds, and then turn it off and see how long it takes for the system to go back to a stable environment. We could use a transient analysis to figure that out. I think one of the big building blocks of SolidWorks flow simulation is fully integrated into the SolidWorks environment. With some other tools, you may have to export your SolidWorks model, run the analysis there. If you need to make a change, you go back to SolidWorks, you make those modifications, then you push it back out to the other tool and reset up your analysis. By being completely inside the SolidWorks interface, it means that if you know how to use SolidWorks, you probably can use SolidWorks flow simulation. Second is it's always watching for your SolidWorks model to change so that it can then update your SolidWorks flow simulation. And there's also coupling with SolidWorks simulation, which means that, based on things like the fluid flow pressure, we can understand how the system deforms. That might be really helpful if you're out there designing a wing or the wing strut. And the last note that I have on there is discrete simulations, parametric sweeps, and optimizations. So most of the time when people are running and setting up analyses, they have specific things that they want to look at. Maybe they want to look at a flow simulation at 10 or 30 meters cubed per second. Those are really discrete simulations. Now, that sometimes is a specific way of using SolidWorks flow simulation, but often you have a lot of ideas that you want to look at, and that's where parametric sweep and optimization comes in. So with a parametric sweep, we can tell the software, you know what, I want to look at the whole range of flow simulations and flow velocities from 0 to 100 meters cubed per second at 10 meters per cube intervals. SolidWorks flow simulation will sweep through and run all those different analyses for you and provide data back on the trends and what actually happens inside your system. Parametric optimization is one step above that, and you can actually tell it to search for a specific goal. So for example, maybe in our electronics cooling example, we know that a certain fan can flow from 0 to 10 CFM. We don't know exactly what flow rate that we need to keep a part under a certain temperature. A parametric optimization would run through a design of experiments to find out exactly what flow is required to keep the temperature at that specific value. So another way that SolidWorks flow simulation can really help you. So that's the basics of SolidWorks flow simulation. let's talk about what happens in electronics cooling and the features in SolidWorks flow simulation for electronics cooling. So, the basics are there. In electronics cooling, we start talking about things like fans and heat sinks, maybe contact resistance between the components. You might have a component bonded to a PCB with, some kind of contact improver, or even a way to add sealant between two components. That might affect the conduction between the components. We can apply those contact resistances. We also have things like thermoelectric coolers, perforated panels to be able to understand how the flow might be restricted by a panel inside the system. And also porous mediums. You may have filters to prevent, dust particles or things like that to get into your electronics cooling module. We could actually use a porous medium to do that. Inside SolidWorks flow simulation, there's also an additional add-on tool we call the electronics cooling module. Basically what it is a set of tools to improve your productivity inside of SolidWorks flow simulation that's really specific to the electronics cooling industry. The ones that are in there are the Pcb Generator, and you can see a screenshot of how that works. We know that a PCB has orthotropic material properties. The material properties through the board are different than across the board. What the PCB Generator allows you to do is plug in all the layers for your PCB Generator, the amount of percentage copper covering, and then it calculates those material properties for you. Certainly you could do that on your own, but the PCB Generator really makes it easy for you. Same thing for these additional properties, 2R components and heat pipes. Those are specific parts inside of electronics cooling enclosure that you want to validate. And up until today, up until the electronics cooling module, those are things that you had to build yourself. Well, the electronics cooling module allows you to put them into your assembly really, really quickly just through the engineering database. And speaking about the engineering database, inside electronics cooling, the number of fans that you have, the number of materials, the number of radiative properties that you have are significantly more than you have in the basic SolidWorks flow simulation package. Now, one that I haven't talked about yet is Joule Heating. I think Joule Heating is actually a pretty cool functionality inside of the electronics cooling module. For example, if you have a bus bar inside your model and you know that it makes a certain amount of heat, you can certainly apply a volumetric heat boundary condition to it, saying that that component makes, say, 4 watts. But we know that based on the geometry, based on the materials of that part, that heat distribution might be a little bit different. Well, with Joule Heating, instead of just applying a volumetric heat to that component, we can actually tell the software, one is what the electrical conditions are. So on one side it's 0 volts, on the other side it's 12 volts. And it will actually calculate the current through the part based on the resistive properties of the material that you've applied. So something like your common household iron is based off of Joule Heating. That would be something that we could use the Joule Heating module for. So what do people use SolidWorks flow simulation for in the EC world? Well, the most common one would be, understanding the fluid flow and heat paths inside the model. Again, going back to the original idea of why people use analysis is we want to understand what's happening in the system. And with flow simulation, we have the ability to better understand how that works versus what happens in the physical environment. A big one I think is also important is understanding what the temperatures of the components are. That's really usually the goal of any electronics cooling project. All the things that exist today that have electronics in it, the designs, the enclosures are getting smaller, and the heat is getting higher. And as the heat gets higher, we know that the performance degrades on those parts. And what we want to do is make sure that whatever heating and cooling tools that we use are actually making sure that the component temperatures are where we need them to be. And we also want to do things like understanding how our heat transfer tools are working. Whether we're using passive cooling or whether we're using active cooling, we want to make sure that fans are in the right spot, that vents are in the right spot, that we have enough holes inside of our vents to be able to handle the heat that's actually happening in the model. Again, if you're doing this with a physical prototype, it's a guess and check method. Start with some locations, Then if it doesn't work, maybe we cover it up with cardboard and move it over a little bit. I've seen a lot of that in the physical testing that I've seen and worked with customers on before. And we may just want to optimize the enclosure size. Every day, the marketing people here come to us and say, hey, we need things to be a little bit tighter, a little bit smaller. Well, that happens in the design world too. They want smaller enclosures. They want it to be inside your pocket. You look at things like the iPhone. Every generation's gotten a little bit smaller. Well, all those electronics engineers that are out there are also having to deal with more heat and making that enclosure smaller. Things like SolidWorks Flow Simulation help them do that. So before we get into talking about SolidWorks Flow Simulation, I want to kind of talk about how our services work. Is often we have customers come to us, just going to turn all these guys on here, with a project, and really what we want to do is find a way to help them out. So generally, if you look at the top graphic, our services start by some kind of discovery call. And really that's where we talk about the problem and understand what exactly we were going to do. Is it something that you guys need to offload and have us run, or is it something you want to get some more training on? That's really what happens in our discovery call. Then we develop a scope of work, we get sign-off. Chris and I will go and take that project, set it up and run it, and then we deliver you guys the results and review the results with you so you guys can make your design decisions and eventually sign off on it. The graphic to the bottom right-hand corner talks a little bit about where I think in the discovery process we really help customers understand what the best fit is for them. There's usually two criteria that exist. The first one is where you are in the schedule for your project. You're either on schedule or maybe behind schedule, or you're ahead of schedule. And also usually you're looking at how often am I going to do these types of analyses. So either it's daily or it's infrequently. So you can imagine in situations where you're on schedule or behind schedule, and you infrequently do these types of analysis, you're in the bottom left-hand corner of that graphic, and that's where analysis consulting is the best fit. Because, again, we're going to offload that work from you, be able to run that analysis for you, give you guys the results. On the top right-hand corner, if it's something you're doing every day, and you know what, the project's going to come up in a few months, gives you some time to catch up, that's where training and mentoring really comes into play. Because it allows you to get everything that you need in advance, and it's something that you can use from a day-to-day perspective. Again, I won't go over the options that we have, but again, consulting and also training, we offer pretty flexible billing. If it's a really well-defined scope, we can usually build a project around it and give you a single price. If it's a little bit more general, we can do things from an hourly perspective. We have really competitive rates. And again, our standard turnaround time is about 10 to 12 business days. But if you need something done quicker, not a problem. Give us a call, and we have options for priority service. We'll just get it done as fast as we can. And just for those that haven't seen flow simulation before, I want to just take a look at it real quick before we talk about how we've worked with some customers from our services perspective and worked in SolidWorks flow simulation and electronics cooling world. So here we have an electronics enclosure, pretty standard. We have a bezel on the front. We go and hide the outside box or make it transparent. We can see we have some electronics components inside here connected with heat pipes. We have a heat sink. We have a fan that's pulling the air out. And we also have locations for air to be pulled in or out of the system on both sides and also on the bottom. So from a SolidWorks modeling perspective, you can imagine your model might look a little bit more complicated than this one. But from taking it from your full-on design for manufacturing and drawings to what you need for SolidWorks flow simulation, it's really a matter of just adding a few components to block off where the inlets and outlets are. So you can imagine, you can see here, we just put a block on top of these outlets at the top. We put a block on the side ones. Again, we're just trying to tell SolidWorks flow simulation that we're doing internal analysis and we really just want the flow to exist inside of the model. So once we pre-process the model, we also do things like simplify it. No PCB has just these 3 components on it. There's often a lot more other components. If those components aren't blocking airflow, generating heat, we probably don't need them inside of our SolidWorks flow simulation. So we usually eliminate those and suppress those. We do that easily using SolidWorks configurations inside SolidWorks Flow. The next thing we do is we can come in here and turn on SolidWorks Flow Simulation. For anybody using network licenses, just remember, left-hand side turns on SolidWorks Flow Simulation for this session only. The right-hand side turns it on for every session. So if you're turning it on for every session, you're always going to be pulling that Flow Simulation license. You might have a guy knocking on your door asking you why you're using it when they may need to use it. So if we start from the top to the bottom, we can take a look at how a SolidWorks Flow Simulation project gets set up. And how this is all set up is using our SolidWorks Flow Simulation wizard. So I'll start it up here, and you can see when we start walking through the setup of a problem, it's a really easy and simple setup. Basically, if we look at how this problem is set up, it's an internal analysis. We've turned on heat conduction in the solids, meaning that in addition to solving the fluid flow problem, it's also going to solve the conduction problem. We've turned on gravity. You can see in the negative y direction, we have gravity pointing downwards. That's going to also include the natural buoyancy effects of air. So hot air is going to rise, cold air is going to go to the bottom. And then we've told the software that we're going to use air. And again, this is using our engineering database that holds all of the information about the materials, heat sinks, fans, porous mediums, printed circuit boards, everything in a database that we can share among all the users that use SolidWorks Flow Simulation. We tell the software, what the default material is. If we don't have a material inside SolidWorks or we don't apply material ourselves, it's going to automatically use that material. We tell it what the wall conditions are on the outside of this analysis. In this case, we have it set to a heat transfer coefficient. The environment's at around 10 degrees Celsius or 20 degrees Celsius, and the heat transfer coefficient is around 10. So I would assume this model is in an environment maybe inside your office, where there's not a lot of convective coefficient or convective heat being able to pull heat out of it. It's really got to rely on the fan inside of this model. And initial conditions, we just basically told the software that when this analysis starts, it starts at 20 degrees Celsius, and we want to understand what happens over the course of time. We also take a look at the mesh. The mesh settings that we have inside SolidWorks Flow Simulation are pretty similar to SolidWorks Simulation. On the left-hand side, you have a really coarse mesh, which allows you to get analyses done quickly. Right-hand side, you have more elements, you have more cells, you have a longer solve time, and potentially a little bit more accuracy, better capturing in the geometry, et cetera, et cetera. When we're setting up and running these problems, we really want to start like a 1 to 3, just to make sure everything is working the way that we want. Then eventually we'll improve the mesh to just make sure the results aren't changing. We don't have any numerical inaccuracies in our problem. So the first real step in our problem is to set any materials for any parts that we may not have applied originally. So you can see in our heat sink here, we've applied copper. So instead of the software assuming that it's aluminum, it's going to assume that it's copper. We then tell the software, how does the flow get in and out of our problem? In this case, we have environmental boundary conditions on all the faces that we've blocked off inside of our model. And then to get flow into our model, we've actually created an internal fan. Again, this pulls from their engineering database. We just go in here, we can pull any of the fans, and it's just a curve of how the fan performs based on the pressure drop across its two faces. A few of the other things in here, contact resistances. So between some of the components, we have contact resistance to maybe prevent some of the contact. It's not an ideal bond. Maybe we need to reduce it a little bit. And then some of the other things that we use are perforated plate. So in this case, instead of having to mesh all of these holes, we've told the software, there's a perforated plate here, and that plate is basically 50% free area ratio. And we can modify those and change those to see what kind of perforated plate we need to get the performance that we want. Some of the components from the electronics cooling module that are in here, we have some 2R components. So again, pulling from engineering database, we apply the heat and also has the properties of the junction and the case inside of the model. We call those smart parts. It basically is a way to quickly generate those parts inside of SolidWorks flow simulation with one step instead of having to generate individual components, apply those materials, apply the properties, apply the thermal resistance between the components. It's all done in one kind of step. And we have our printed circuit boards in here. So again, we've looked at, we talked about this earlier, is setting up the layers and the percentage cover and the material properties to generate those PCB boards. We've also added some goals. I like to use goals to as sensors, essentially. It's easy ways to pull out data really quickly. It exports it to Excel. You can compare side by side without having to do any picking, clicking. It allows you to export data really quickly. This also tells the software what parameters you really want to focus on, and you can use them to understand how stable the solution is. So let's go take a look at a few of the results. Again, the most common results that we take a look at are cut plots. Let's go and show these cut plots on our screen here. There's a really handy option inside SolidWorks flow simulation to turn off the geometry real quick, so we can take a look at what the geometry looks like or what the flow results look like without having the geometry turned on. And again, like we were talking about earlier, is there's only so many thermocouples that you could put inside of a physical model. Inside flow simulation, we can use the probe tool to basically put thermocouples anywhere that we want in space, on components, to take a look at specific locations and what those temperatures are. And it's a really quick and easy tool to be able to do that. So let's turn off, let's delete these guys, remove them from our screen. Another thing we might want to do is let's take a look at what the surface of the heatsink looks like, what the temperatures are on that heatsink, and also on the PCB board. So again, surface parameters allow you to plot what's happening on the surface. Cut plots allow you to plot anywhere, through a part, through a space, to be able to look at exactly what's happening. And again, the probe tool works the same way, being able to select anything that you want. So again, SolidWorks flow simulation setup the problems, pretty straightforward. Work from the top of the tree, work to the bottom of the tree. Then once you get to the results, you just grab what you want to do and what you want to output, and take a look at some of the results from the analysis. Some of the other features I'll talk about that we use quite often when we're working with customers is, again, the goal plots, being able to export these to Excel really quickly. Go here and show you what happens. Again, it pulls all the data. These are all the parameters at the very end of the analysis. It allows you to take a look at what happened. You can see that for this mass flow rate, it started out as a value up here, and then it started converging towards the solution and flattened out. So pretty easy to pull the data out of the model. And you can see there's other things inside the model we might want to take a look at, like point parameters or surface parameters or volume parameters. Kind of how they sound is I can select any point, surface, or volume and understand what the values are at that location. XY plots, I think, are pretty powerful. Allows you to draw a sketch inside of SolidWorks and plot the result along that sketch. And then report and animation. Animation is straightforward. It basically allows you to see what's happening inside of the system. So for example, if we go here, we'll turn off this surface plot. Maybe we were interested in a flow trajectory animation of how the flow works in the model. We can go here, plot that, and then we can animate that. I don't know how well it's going to come through on the GoToMeeting. We'll give it a try. Let's switch it to a different mode. I like to use the arrows flat option. And we'll make them a little bit bigger. And then we'll just animate them. This might be something helpful for your flow simulation to understand how things are working, but also this is something that those people in marketing really like to have to understand how things work and to show your customers how it works. So with that, that's kind of the basics of SolidWorks flow simulation. We'll go back to the PowerPoint here. And we'll talk about a few customers that we helped out. So here's customer number one. I call it the quick and dirty. They were working on a conceptual design. Really what they were working with is they had an existing design They knew how it worked, and they just had to scale it up. And really what they wanted to know is, if they scaled it up, how much did they have to scale up the fans and also the perforated panels on their model to make sure that they had enough flow inside of their model to cool the components. And the issue that they had in their design cycle is they were waiting on the electrical engineers. The electrical engineers didn't know how much power this new design was going to have. They didn't know exactly what where the components needed to be. They knew that they were going to be in kind of the same location, but they really didn't have an idea of how to approach the thermal part of the problem. So what we worked with them on is better understanding what the existing characteristics are of the flow problem and the existing design, and then helping them scale it up. These guys were kind of under the gun. They didn't have SolidWorks flow simulation. They didn't really have time to take the software, get it in-house, and learn how to use it. So what we did is worked with them from an analysis consulting perspective. We took their problem, we updated the model, we built the models for flow simulation specifically so we could move things around if things didn't work the way we expected to, and then really evaluated the flow inside the model, make sure the velocities were what we needed and were close to what we had in the previous model to really understand how the problem works. So again, if you don't have the software, or you're under the gun, you don't have the time to run these simulations, this is somewhere that we could really help you is in the analysis consulting side of things, is taking your problem, solving it for you, and then getting you back the results. Customer number 2, this is a case where they had the software, they came to training a few months ago, and they got into a case where they had a little bit of time. And when you have a little bit of time, that means you can spend a little bit of time on training. And they had gone to our basic training, and I kind of equated to driver's ed. If you come to driver's ed, you learn how to drive a car, you learn the basics, but nobody's going to let you go out on a racetrack. Mentoring is really what we would do to kind of teach somebody how to apply it to their software, how to apply it to their specific problem, and that's really what this customer wanted. The other piece of this is they wanted to understand how confident they could be in their results. So they had an existing unit, and they wanted to have us help them set up the problem to get results that matches what they were seeing in real life. And in the long run, we actually got this down to being only 3 or 4 degrees different from what was happening in their physical situation, which was a total success for them, gave them a lot of confidence inside how the software works. So what you can see here in this situation on the far right-hand side is kind of what we would do from a mentoring perspective. You can see this is an outline of our mentoring session for this customer. It's about a 3-hour session. We talked to them about, how do they get help when we're not around, how to plan your analysis, simplifying the models, setting up the problem, how to get output. In this customer's case, they really wanted to know how they could go from their enterprise PDM vault to a simulation and then back into enterprise PDM for archiving, because they hadn't really figured out how to do that. So one of the big features of this project was, you can see I've blurred out these examples for the customers because they're confidential designs. You can see it was a pretty complicated, really nice SolidWorks assembly that they could use for anything, manufacturing, marketing, design, but it was difficult to use for flow simulation because there was a lot of features in it that they really didn't apply. So a major topic that we had with this customer was really understanding how to simplify the model and how to start small and build up to the final model to get results that actually were accurate. So again, if you're in a situation where you have some time and you really want to understand how to set up and run a problem, we can help you with our mentoring solution. And the last one is kind of an example of a customer that we started from beginning to end. Their long-term goal was that they really wanted to use CFD in their design process. Today, everything was done with physical prototypes. They would actually 100% design a product, build prototypes, take it out and test it. If it didn't work, they just started cutting up their prototypes to make it work. They would, desolder components, move them around. They would cut holes in electronics enclosures. They would cover up holes. They would put more fans, whatever needed to be done to make it work. And they spent a lot of time on that prototype side of things when things didn't work. So what they really wanted to do was be able to bring CFD into their product design cycle, but they were stuck in one situation, which was they had a product that they needed to analyze that day. So this is what I almost call like an all-inclusive package from Hawkridge Systems. We started off by doing an analysis consulting project. We set up and ran their whole problem, helped them to improve the design through a couple of iterations, and then we got them the software, then we brought them into our classroom training to teach them basics, and then we went back and took that analysis consulting project and did a mentoring project on it. So we set up and ran the problem, showed them all the things that we did, kind of like the magician showing you how the trick works. That's what we did in this case for this customer. So some of the things to mention here is that we do have some incentives to be able to help customers with this all-inclusive need. Is we provide 25% of the consulting fees back towards the license purchase, and then if we take an analysis consulting project and turn it into mentoring, we also offer 25% of the we offer a 25% discount on the mentoring, and if we combine training and mentoring together, we give you another 15% discount on those two pieces together. So in the end, this customer got everything that they needed. They needed the results right away. They got the software in-house, quick turnaround, and actually got a pretty good deal overall on everything that they needed. And I kind of wanted to mention is, another challenge this customer had was really concurrent design. Today their process was 100% linear. Design, test, iterate. By integrating CFD and Solidworks flow simulation into their design process, they now can do both of those things in parallel. If they're doing some testing, they can always do other testing on the CFD instead of having to wait for those tests to actually be done. So that was another kind of way that we were able to use flow simulation to help these guys out in their problem. So we're getting near the end here. I just wanted to throw out a few summary points. So again, we want to use analysis to really reduce your product design cycle by designing and using your virtual models for all the testing. SolidWorks flow simulation for electronics cooling is definitely the way to go if you're using SolidWorks today. Again, it's integrated into the SolidWorks environment. The electronics cooling package allows you to do a lot of additional stuff and improve your productivity for those types of problems. And if you're stuck, let us know. We're here to help you guys out, whether you need us to set up and run the analysis or help you out with some training. Our goal here is to give you a solution, whether it's software, training, or running the analysis that solves all of your problems. A few things that I want to mention just before I close things out. There are some promotions going on. The first one is a mix and match. If you are looking to buy some additional software, there's a buy two, get one free kind of thing going on right now. We're also offering 20% discount on training and our consulting services. And then there's some undocumented or non-promoted promotions on software, CAM and 3D printers that your SolidWorks sales representative can help you out with. And on the consulting services side of things, we definitely have some things, some promotions that we always have. We talked about the 25% back on consulting, up to 30% back on mentoring, and also our 15% discount on our simulation education bundle, which is training and mentoring together. Webinar Wednesday is something we do every week, similar to this presentation today, where we're talking a little bit about how the software works and how the different features work. We have a few other things coming up here on enterprise, PDM, e-learning, on CamWorks, electrical, pretty much anything from a SolidWorks perspective. We have an event that we can both show you how the software works and also tips and tricks along the line. So if you have any interest in this stuff, here's your contact information. Definitely talk to your sales rep or contact us through a toll-free number if you have any questions about getting the software in-house. Maybe you have SolidWorks flow simulation today, but you're looking to add that electronics cooling module. Give us a call. We'll work that out. If there's anything along the lines of needing an analysis done or training services, you can contact me, Jared@hawkridgesys.com, or my phone number, 650-230-7006. And again, let us know what you guys are looking for. We don't charge you guys to talk about what we can do to help you out. We'll help you architect any kind of solution that you need. And we'll have more information about our services and the software on our website. And we'll be posting this video if you guys want to go back and review it at any time. So I want to thank everybody for attending. Chris and I will be here for a little bit to answer any questions that you guys have. So just feel free to use the chat panel to ask any questions. And again, thanks for joining us today for this webinar, and have a great Thanksgiving week next week.